So let's begin with the session. Um, Hi Sahara. So I think no one is going to come now. Um, let's begin with the session. So Sahara, have you come up with the third week assignment? I mean, have you seen that, or I guess the timeline is already over.
Yeah, I have done that.
Mm-hmm.
That also.
So do you feel any like? I mean, what was the main issue? Did you feel about it, or is there? I mean, how was the assignment basically? That's my question.
Hello, sir. Actually, currently I'm outside of the house and I have no book and other my stuffs. So I will just tell you about the assignment and
Just
everything.
one second. So in that case, I will just share my screen, and you can see in the screen itself and then tell. Just wait a second.
Yeah. Okay, sir.
Yeah. So Sahara, you might be able to see my screen now. So question one. Let me actually start with discussion itself with all these questions. There are about 10 questions. Uh, so the question was, we have to choose what algorithm does. First question says choose the incorrect statement. So our first statement is ergodicity always implies stationarity. This is actually correct. Ergodicity, it means that when you have in long, like if you take the readings, if you track the trajectory or the pattern for a longer period of time, is equivalent to having shortest period of time, but many more number of trajectories or patterns. So that is ergodicity, and yes, that always implies that there is a stationarity in the system. Evolution of variance is uh, in time is deterministic in a trend type non-stationary process. So this actually comes directly, even said it's there in the notes itself. So I don't think so. I have to tell. Basically, you can see even the answers. It's already there. The an integration type integrating type non-stationary process has bound variance, which is actually false. The reason is you can not actually tell that whether it's bounded or unbounded. It can be unbounded also. Second question, is that a random process? So this is a random process. Covariation, stationarity. That was the question. Phi and f are constant. and a is a random variable. Let me just open the solution of it. Hello Shobna. Let me just open the solution of it. See, if you take this random variable uh, vk, so expected value, see, cos square expected value is 1, so we can say that expected value of ea is 0 and variance of a is 1. This is cos variance is 1, basically cos square, and ea square is equals to variance, so that could be taken from the fact that you can just I mean, this is a random property, so that comes ea square equals to variance square plus ea expected square, that goes to 1. Now the question was to find out whether there's covariance stationarity, I mean whether it's stationary or not. So if you try to calculate all the four parameters, I mean, if you try to calculate the covariance, you will see that it will come to be not coming to be zero. If it comes to zero, you can say it's stationary, but it's not there. Therefore, there is non-stationarity, and it is actually time dependent also. Therefore, it is the answer for this is no. The third question says, given below the time series plot of CO2 level in the atmosphere, the same even sir has shown this a lot of time. So choose all the correct statement about the time series. So I guess you can see from the graph itself, with time the concentration of CO2 is increasing. We can always, I cannot say it is stationary, but yes, it does have trend. It is periodic in nature, but it is not ergodic. Ergodic would mean that, let's say, if assuming that, let's say, if I choose ergodic will mean that for a small period of time, if I take uh, let's say n readings, this should be equal to for a longer period of time. That would happen in sort of where there's saturation sort of system. Then you can say, or it's already a constant system sort of. But this is not. This is increasing in trend, so this is not ergodic. So fourth question: select all correct statements about autocovariance function. One second. So even sir has said that mean changes with time, therefore it's non-stationary, and since it's not stationary, it's not ergodic also, and it has a trend that we can see, and it's even periodic. And if you see, if you can't, it's like there are 10 peaks, so it is sort of with yearly it is happening, the increase and decrease of the concentration of CO2. See, correlation variance function, auto covariance function tells you, if you have to say that if a system is independent, you have to be uh, like the covariance system should be zero. The covariance should be zero. The autocorrelation one should be zero. Since v can vk minus one, so the question was, uh, is vk and vk minus one are independent? Sorry, I mean not is, vk and vk minus one are independent if acvf between them is zero. So this is false, because uh, independence is not checked by ACVF. It is checked by C itself, only covariance or correlation function, not this one. Any symmetric function can be the ACVF of a stationary process. That is not true. See, what happens is, you can even take, let's say, uh, a system that has a lot of fluctuations throughout the mean. That is sort of stationary, and even if their fluctuations are very large but not symmetric in function, so then in that case the function is still symmetric, but ACVF would cannot be the I mean system would be stationary, but you cannot say that it is a function of ACVF, because a function that has this a lot of fluctuations throughout the mean would not give that. ACVF is affected by confounding effects. So let me tell you what confounding effect means. When you have, let's say, three variables, you measure only two variables, and all three are dependent on each other. Irrespective, let's say you have a variable A, B, and C. A depends upon B, C depends upon B, and we are trying to see how A is changing with C, or C is changing with A. You can see a trend, but it does not apply that uh, A is affecting C. It is one confounding variable, confounding parameter that affects both A and C. So since A and C are being affected, so ACVF itself would be affected by confounding. So if there is a third variable that affects both of them, then ACVF will also be affected between these two variables. And non-negative definiteness of ACVF implies that spectral distribution exists. That's true, because if it is negative, it would become indefinite or semi-definite. Sorry, zero becomes semi-definite. Negative will become indefinite. Now calculate the autocorrelation function at lag 1 and lag 3 for the following stationary process Vk. So this is very simple. You can just this itself, if you take the integral from I mean, what is the given? So lag 1 and 3. No? So between 1 and 3, if you take the integral, one second. This is the lag function at lag 1 and 3. And it's given. Let me just open the solution itself. So if you open, since both are e functions, so yes, you can have these. Expected value of this lag function is would be 0. The variance of this lag function can you will just have to square it. If you square it and take the expected out, obviously you can simplify all of this. C1, C2 both are constants, they come out. Then you can take expected value of e squares. That is simple. What you will be left with now is, since you have to take that autocorrelation function has to be made, that matrix has to be made, and then you can have this a1 star divided by a2 star. So I mean, this is a basic question even sir has done in the class, so I don't think so the I have to do it. If you have any questions, you can actually ask. I'm there to solve your questions. Calculate autocovariance function of the stationary process Vk at lags 0 and 3. This is also very similar to what was there above. Which one of these is valid autocovariant function for a stationary process Vk? Since autocovariant functions, if you take L to be negative, since autocovariant mostly are defined from starting from 0 to more than 0, and they are symmetric in nature, therefore this system goes, otherwise this does not, and these are not symmetric throughout the nature. So option D is the answer. You have to check whether it's symmetric, whether it's I mean there are no broke, I mean it's bijective in nature, and there's no, it's continuous in nature. Choose all correct statements about ACF. The theoretical ACF of a Gaussian white noise cannot be calculated without knowing its mean and variance. It can be calculated uh, without knowing it, because there are, I mean there's a simple standard formula for that that can be used. Even I guess it's within the solution also. See, the theoretical ACF of a Gaussian white noise is fixed as 1 at k equal to 0 and 0 elsewhere, irrespective of the underlying Gaussian. The reason is, see, Gaussian white noise you can take as like a direct delta function. It's just sort of a peak at k equal to 0. That's a theoretical Gaussian white noise. So B is given, the answer is correct. So let's talk about C and D. Sample ACF of a MA process estimated from a finite sample is 0 for lags greater than Q. The reason is it can be greater than 0, but it's not a necessary condition that it should be 0. That is why this option is incorrect. It's not that it's not possible, only the fact is it's not a necessary condition. And ACF helps identify the order of an AR process. That's not correct. ACF does not help that. ACF of a AR process decays to 0. And ACF helps you identify for a MA process, not an AR process. Consider the noisy observation of a sinusoidal signal to be VK plus some error, where EK is a non-zero mean univariance white noise sequence, and A and F naught are constant. Define the sample covariance function as this thing, where V bar denote the sample mean, N is the sample size, frequency of the sample covariance is N tending to infinity. At N tending not it's not as, it is at N tending to infinity for a very very large system. If you see the formula, it is like This is the question. So when n tends to infinity, the small noises, the errors that comes, no, they diminish. That is why the main signals f naught is only left as the frequency. Therefore, f naught is the answer. For example, you can see n by n minus 1 f naught. If this actually comes, and if I take n tend to infinity, minus 1 would become negligible, and this will only tend to f naught. Find the a.
Hello,
Yes, Sahara.
hello,
Yes, Sahara.
sir. I didn't got that ninth one because my answer was two F naught.
Oh, your answer was coming to f naught.
Yes,
Okay, just give me a minute. Uh, can you show me your answer? I mean, is it possible for you? Because I did it. I got it f naught.
it is not possible for me to show my answer. But can you show your answer so that I can identify my mistake where I was mistaken?
Yeah, yeah, sure. Just give me a moment. I'll show it. Sarah, can you give me your email ID? Actually, right now my this tab is not working, and my I'm not able to write this answer. Otherwise, I would written that here. In other all my other classes, I have written the solution and told the students. But right now tab is not working, and neither I have my notebook with the solution right now. I had a different notebook with
Yeah,
me.
yeah. Okay,
You,
okay, sir.
can you
Okay,
just
no problem.
No, no, I will actually email you the solution. The,
Okay,
no, no.
fine. Sahara
Mm-hmm.
Sahara Sarday 8 @ gmail.com.
Sahara Saturday
8
8 @ gmail.com.
@gmail.
Okay.
Yeah, all letters small.
Yeah, I will surely
Okay.
send this thing.
Yeah.
Okay, that's
And sir, sorry for the inconvenience that
no,
was
no,
outside.
no, no, no problem. There is no inconvenience. I'm able to hear your voice clearly. Find the best model to fit time series. So this the last question you have to do using R. Were you able to do that using R? The data set is already given at the top. You have to use that and fit the best model. So either it's EK or it's AR or MA.
Sir, here I thought that AR1 model will fit best, but it is the white noise.
Uh, how did you
So
check it whether it's AR? I mean, obviously four options are given. It could be of order one, it could be of order two. But how did you check whether it's this thing? I mean, you had said you took AR2 or AR1.
AR1.
But why?
Sir, when I was referring to the notes, lecture
Hmm.
notes,
Hmm.
then I then I saw about AR1 and then I tried to fit, but then actually I
Hmm.
uh, the last question I was confused in that question.
Hmm. Okay.
So
No issues. No issues. That happens. Happens. I'm very happy that you have tried all of them and you're doing it.
I also tried about moving average MI1,
Hmm.
but it didn't fit to that
Moving average would not fit
series.
there. Uh,
Yeah.
White noise will actually be. I mean, would not perfectly fit, but it's sort of almost the best fit. Uh, so do you have any other questions? If not, I mean, we can end the session because right now, see, what size teaching is actually, I mean, far. Uh, I mean, he's teaching extremely fluently and impeccable. So there's nothing that I can add to it more.
Yes. I also think that the lectures are very detailed and it took me so long to complete those lectures, really.
Yes, 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 yes.
So,
If you are
I have no doubts.
no doubt, I am here only for other students also who come. Uh, if you want, you can leave.
Okay, sir. Thank
You
you.
sure? Thank you so much.
And sir, sorry once again.
No, 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 no. Sorry, required.
Hello, hello, sir.
Yeah, Sarah. Yes, Sarah.
Good evening. Sorry, sir. Uh,
Mm-hmm.
I was curious about the paper pattern of the paper exam and what kind of questions would it be descriptive type or all sums and all.
It will be just like your assignment. See, I'm telling you from my own
Okay.
experience. NPTL, uh, if you do your assignments well, you will be the top scorer. That's it.
Okay. Okay.
There's
Okay.
nothing else because all the questions are made in order to cover everything, and you have diligently work on them. So there's no point of, I mean, question. And you do need not study from anywhere else. Even the question pattern would be only MCQs, and
Yeah.
obviously no R would be there. You would not have to use R. That's why answers
Yeah. Yeah.
would be very. I mean, it would be possible for you to calculate in within time, and sums will be actually less. It would be
Okay.
more of a qualitative answers, just like ACF, MAN. Uh, what are these? And you will in future we will have a lot of mean square displacement. All these things will be there. So such sort of things will be there, which is more of a qualitative, not. It would be quantitative also. You have to calculate, but that will be lesser in number.
Okay. Okay. I was just curious about the paper pattern and the paper. Would it be so difficult or
No,
what?
no, it won't be
So,
difficult. I think you are already doing fine.
okay. Okay, sir. Thank you.
Okay, Sarah.
Bye bye. Have a good day.
Same to you. हाँ बताओ। आप बताओ। हाँ ठीक है चलते हैं। मैं हाँ हाँ, 8:30 पौने 9 तो चले प्लीज। ठीक है। Let's end the session.